A particle has a displacement. A particle has a displacement of 12 meter towards east and 5 meter towards north, then 6 meter towards 5 meter towards north and 6 meter vertically upwards. Find the sum of find the magnitude of find the magnitude of the sum of three displacements. I represented S as the displacement. Let us draw the diagram, a reference diagram. You know, this is north and this is east. That is x-axis. Positive x-axis is east and the positive y-axis is north. Of course, this is west and this is south. Now the origin is O. Let us consider initially the particle has undergone a displacement 12 meter towards east means OA. Then there is a displacement towards what? North. Okay. Around what? That is 5 meter, right? So 5 meter towards north. And then again vertically upward 6 meter. Vertically upward 6 meter. Okay. So this is B and this is C. This is 6 meter, this is 5 meter. And what about this? 12 meter. Now you have to find out the net displacement, which is nothing but OC. Okay. So what is OA here given? OA is 12 meter. And what about AB? AB is 5 meter. BC again 6 meter. Right? Now, according to polygon law of vector of addition, we have to apply the polygon law. What is the concept here? Polygon law of addition of vectors. So we have to consider this OAB first. Okay, in order to find out this OB. So let us consider triangle OAB and we have to find out OB. So OB is nothing but the whole square root of that is OA squared plus AB squared, right? So, and in fact, we are interested in OB. So we have to add this according to Pythagoras theorem, the square of the sum of squares of adjacent sides and opposite side. So OA squared plus AB squared. So can you find out what is that? What is OA? 12 squared. What is AB? 5 squared. What is the answer? 13 meter. So OB is 13 meter. Then we have to consider OBC. So triangle OBC. So in that case, so we have to apply the OC, which is nothing but once again that is OA OB squared plus BC squared. This is, yeah, it is a right angle actually. That is, it goes in this way only. This is right angle. Okay. So OB is OC squared. That is OC is equal to OB squared plus BC squared. Okay. Now you have got already OB. Therefore, 13 squared. And what is BC? BC is how much? 6. So 6 is squared. Because it is set vertically upward. So from this vertically upward. So that is why I have taken 90 degree, right? So 13 squared plus 6 squared. What is the answer? 205, right? 169 plus 36 means 205. I think on that day I already taught you the division method to find out the square root. Can you do that? Hmm. Now you must tell. I already taught you. You must tell. 205. You have to take two digits. So two digits. Now tell me one time. That is, you have to take the perfect square of the selected number. So you have got 2. What is the perfect square? 1 squared only. So 1. Then remaining 1 put 0, 5. Then whatever the uh, quotient coming here should be multiplied by 2. Remember, whatever the quotient coming here should be multiplied by 2. So 2 into it should be multiplied by 2 every time. So this is 2. Okay. And now once again you have to go for the perfect square. So can you get me the perfect square so that it should be less than 105? What could be that? How 10 tens? If you put 10 means you have to include this 2 compulsorily. So when it, uh, we can take how much? 4. Shall we try? Okay, 4. So 4 fours are 16 balance 1, 8, 9. Got it? And therefore the remaining is how much? 15 minus 6. Tell me, what is it? 9. 15 minus 6, right? And put dot, that is decimal point, because we don't have any number, but you can drop 2 zeros here. So drop 2 zeros. Okay. Now you can proceed once again. What am I supposed to do? Again multiply by 2. What is the number? 2, 8. 2 into 14, 28. Right? Now try to find out the perfect square. Tell me. I think I will give you a worksheet based on this. You have to work out. How much? It should go within 900, but you should be a perfect square taking here. Whatever the digit you put should be, we can put 3. Very good. 3. So 3 threes are 9, then 3 eights are 24, balance 2. 3 twos are 6 plus 2, 8. Okay. Again, 10 minus 9, 1. Then 9 minus 4. Tell me quickly. You have to guide me. I am writing in your favor. 9 minus 4, 5. Then what should I do? Tell me, you have to one, not one more, two more. Every time you have to drop two more zeros, right? Okay, and what am I supposed to do? What should I do? What should I do this one? Again multiply by 2. How much? Tell me. Tell me. 628. So I have to put a number so that it should be a perfect number. I have to take only the same number here and here. And it should be less, either equal or less than that. What could be the number? Only 2. Very good. So you can stop with that. Okay. So what is the answer here? 14.32. Got it? Right? I hope now you are able to find out the square root of this. I'll try to give you a worksheet. You have to complete that. Okay, so that you can have some practice. Right, Prisha and Shanvi. Every time you should not say, I cannot repeat the same thing. Right? Got it? So 14.32 meter. So this is the what? The net displacement. Okay? Right? The total displacement is this dash. You got this? So this is a very good example for polygon law of addition of vectors. Okay? Yeah, tell me. Addition of vectors by analytical method. Addition of vectors, analytical method. Let us consider two vectors A and B inclined at an angle theta. Okay, take down. You have got a vector OA and another vector that is B. So this is vector A, another vector B. Okay, they are inclined at an angle theta. So it means you can put like this, extend this, and this angle is theta. Take down on on a particle at the same time. And they are represented in magnitude and direction by two sides OP and PQ. OP and PQ. So let us call it the OP and this is PQ. This is A vector, this is B vector. OA vector is nothing but that is vector A. Similarly, PQ is vector B. This is P. This is B vector. This is PP. This is OP, right? OP is equal to A vector. Okay. So OP vector is equal to A vector. PQ is B vector. And it subtends an angle theta to the x-axis or the horizontal. And now this OQ, okay, so that is the resultant vector R. Get down, that is the resultant vector R. And the angle subtended by the resultant vector to the original vector A is beta. Okay, take down this as beta. And the normal drawn here is QN. Normal means 90 degree. So this is 90 degree. So this QN is perpendicular to that is OP produced. OP is extended, produced. So produced OP or extended OP. That is nothing but ON. or ON, you can say. Now from triangle that is QNP, consider that triangle QNP, that is this triangle QNP, right? Now, what is cos theta? Adjacent by hypotenuse, right? So it means this adjacent means which one? Pn. So Pn divided by hypotenuse PQ, PQ, right? Therefore, we can label this Pn as what? PQ cos theta. Do you understand how? Because Pn is equal to, you can rearrange it and you are able to get PQ cos theta, right? PQ cos theta. So PQ cos theta means the PQ is the vector B. So we can replace this by B vector cos theta. Okay. So this is Pn. Understand this? Then can you proceed with sine theta? Do it. Tell me what is sine theta opposite by hypotenuse. So Qn divided by PQ, right? Qn divided by PQ. And once again, what is Qn here? Which is nothing but, what is that? Qn. Again PQ sine theta. Since we know PQ is equal to B vector, you can put it as what? B vector sine theta. So Qn is represented as what? B sine theta, B vector sine theta. What about Pn? Pn is PQ cos theta, which is nothing but B vector cos theta. And what about this one, Q1? That is B vector sine theta. Are you able to understand this? Okay. Now let us consider the ONQ, another big right angle. Okay. Follow me carefully. ONQ. So consider triangle ONQ. So in that, which is the right angle? Tell me. N is the right angle, right? N is right angle. So in that case, now what is OQ squared? You can apply the Pythagoras theorem here. So ON squared plus QN squared, right? Okay. I got place it there. So we have to consider this, that is ONQ. Let us consider this ONQ, and we had to find out here the R squared, hypotenuse squared, right? So R squared is equal to what? Tell me, what is R squared from this? ON squared plus QN squared, right? So ON squared plus QN squared, right? Now, what is this ON, which is nothing but OP plus PN? Am I right? Okay. Yeah. So it means that is you have got this A, and because we have to take, for example, whenever you take any size on the Pythagoras theorem, you have to consider only the magnitude. So you have to take the magnitude of vector A. Are you able to follow? So it means simply A. Got it? So what do you mean by magnitude of vector A? You can call it simply A. What is the magnitude of vector B, which is called simply B? What is the magnitude of vector R? which is simply R. Okay, so remember this. Now this is A, and what about this? You have got the B cos theta here. So you have to consider that B cos theta. So which is nothing but A plus B cos theta. And what about this B sin theta only? So ON squared is nothing but A plus B cos theta. Do you understand this? So A plus B cos theta whole square plus. And what about the other one? This one B sin theta. Okay, you have to take the modulus. So B sin theta the whole square, right? Now you can apply the formula A plus B whole square. Tell me. A squared plus B squared cos squared theta. Okay. Plus 2 AB cos theta. And what about this one? B squared sin squared theta. So you can combine these two. Therefore, you have A squared plus and B squared being common, you can take outside the bracket. Now sin squared plus cos squared is equal to 1. Okay. Then you have 2AB cos theta. And this becomes 1. Therefore, A squared plus B squared plus 2AB cos theta. And R is the taking square root of this one. So this is the analytical method of finding out the resultant. What's the doubt? Hmm. Now, let us proceed with we have found out the resultant of the two vectors, but at the same time, what we are supposed to do, we have to find out the direction of the resultant in terms of the angle. Do you understand this? Right. Now, let me explain about the direction. So, let us consider once again this angle. That is, let us consider QN, that is ONQ once again. Okay. So in this ONQ, you have got the beta. So what is tan beta? Tell me from this. Opposite by adjacent. So QN by ON, right? So QN divided by ON. So what do you mean by ON, which is nothing but A plus B cos theta, right? So what is QN here? QN is nothing but what is that? B sin theta. Therefore, B sin theta divided by, tell me, A plus B cos theta. Got it? Now we have the direction of resultant. So this is called the direction of the resultant vector. Resultant R vector. Okay? R vector. And now what you can do is you are interested to find out the beta. So you can put tan inverse of B sin theta divided by A plus B cos theta. Okay. Now let us analyze some of the cases. For example, huh? Now we should go by known value only. We have already found out this B sin theta and B cos theta. So it will be very comfortable to get the equation in a reduced form. Okay. Yes, yes. I will explain. I will explain. I will explain. Now let us consider the cases. For example, that is, I was giving this drawing straight away. Okay, let me explain in a different way. 1 minute. See, that is, I have a vector like this. Another vector, it goes like this. What can I do? As I already mentioned, you can bring this vector here, right? So this is phase one diagram. I am bringing here so that it becomes what? Okay. not perpendicular. It goes like this. Okay. So pointing out this is the origin, and you can put O and Q. Okay. So you can, in fact, that is why I call that this is an angle subtended by the two vectors, because, for example, you can fix this one. Okay. You can fix this one. You've got the vector here. Try and place here. Okay. So I placed it here. Now, what is the angle subtended? That is theta. Now I am just keep moving this. Okay. So just moving this without changing the angle so that I can get the vector here. So just to produce this vector, and it subtends an angle theta. Do you understand? So that we can fix like this and find out the resultant vector R here. So this is the trick. Do you understand? For example, I'll show like this. Let me take a vector like this. This is one vector. Okay. Now this is another vector. For example, one bus is traveling here in this way. Another bus is, it is going in this way. Now what I'm doing is, without changing this angle, I'm just bringing here, and so that I'm making a co-initial vector like this. That is stage one. I have not changed the angle, but I have just dislocated without changing the angle. Now I keep moving this to this position. Do you understand this? Are you able to follow? Now what is the angle between these two vectors? Initially, I put the as co-initial vector, and this is the initial vector. Do you understand? This is the theta, right? Now I have taken this vector and put the tail of the vector to the what? Head of the first vector like this. Okay, I think this concept I already explained about this concept, right? Now I can produce this vector. What do you mean by producing the vector? Extending the vector. So that these two angles are equal. So that is why I put theta. Now, when you consider the resultant, it will be different. So it will be a different angle. I have to connect these two. For example, tail of the first vector, head of the second vector. Connect it. Now it is not theta, it will be what? That is beta. Okay. So it won't be exactly theta, instead it will be beta. And that's why I've taken beta. Now we will connect all these points here. Now you had to check it. You do it like what I'm doing, you can find it. Okay. So this is the origin point. This is A, and this is the vector. So let us put P, and this is the PQ vector. This is A vector. This is B vector, and this is the angles. I mean, straight angle. I mean, 90-degree or perpendicular. And this is the extended, that is produced vector of A. Okay. And this portion we have identified based on this triangle. Okay. So what is this? This is B. What is that? Cos theta or sin theta? Sin theta. And what about this? B cos theta. Okay. And we have to consider only the magnitude here. Okay. So, and based on this, this is already A vector means, let me consider the magnitude A. So overall, this is A plus B cos theta. What is this? B sin theta. So that when you take the tan beta, so the idea is to find out the resultant vector of these two vectors. And that is why we are positioned like this. Now you will be given the values like the bus is starting towards this direction, another bus at any direction. So the angle between the two is beta they will give. So based on that, we'll proceed. Otherwise, I mean, the angle between the two vectors is theta they will give. So we have fixed this as theta because you know very well on parallel line, you've got the same theta here. And what about beta? Beta is the angle subtended by the resultant vector to the initial vector. Okay. So probably they will ask what is beta and what is this value. Okay, modulus of r. So in that case, by Pythagoras theorem, we are able to achieve, and by taking the tan beta, we are able to arrive at the angle that is beta is equal to tan inverse of etc. So the point is very clear. Okay, any doubt? Right. So when we solve some problems and study the cases, you will have that is much more clarity on this concept. Now let me proceed with the cases. Now take down when theta is equal to 0. Now you have to tell me cases. Theta is equal to 0 means what? What is theta? Define it. Anyone? The angle between the two vectors. That's all. What is theta? Okay. What is that beta? Resultant. Okay. So that is the angle subtended by the resultant to which vector? Initial vector, the first vector. Got it? Right. So in that case, when I say theta is equal to 0 means if it is like this, if the vectors are moving in this direction theta, then you can call it theta is above 0. Now when I say theta is 0 means what? Is a collinear vector. It goes like this. Do you understand? Got it? It means theta is equal to 0. It lies on the same direction only. For example, one bus is traveling at 80-kilometer speed. Another bus is moving at a certain direction, they say 30 degree, with uh, 40 kilometer per speed. So that is a theta. You can proceed. But when I say theta is equal to 0 means what? This bus has already started and the same direction it is also going, right? So in that case, a 40-kilometer bus and 80-kilometer bus, they are traveling in the same direction. Do you understand this? Okay. So when theta is equal to 0, what do you understand from this? That is, R will be what? For example, R is equal to, what is the formula? The whole square root of A squared plus B squared plus plus 2 2ab, and then put cos, instead of theta you will put 0. Do you understand? You know very well cos 0 is equal to 1, right? So in that case the whole square root of a squared plus b squared plus 2ab, right? So which is nothing but a plus b whole squared, right? The whole square root of which is nothing but a plus b. Okay, so r is equal to a plus b. Got it? So this is case 1, right? You understand? It means this will be maximum. Now let me say, listen to me, let me say, theta is equal to 90 degree. What do you understand from this? Now I will draw, you have to tell me. 1 minute, let me draw, and you have to guide me so that let me check whether you are able to understand the concept. So I said vector A is moving in this direction and vector B is at right angle. What do you mean by that? How I should draw? A right angle I should draw. Got it? So it means this is B. So B vector. It means it makes an angle 90. So theta is equal to, second case, take down. Theta is equal to 90. So in that case, what is cos 90? 0. Then what is our formula? R is equal to, tell me, the whole square root of a squared plus b squared and 2ab cos theta, where that is 0, you have to stop with that because that term becomes 0, right? So in that case, what is the value of r? The whole square root of a squared plus b squared only. Got it? Do you understand? Okay. Then let us proceed with the mm, third one. Okay. Now, let me tell you, these two vectors are collinear but in opposite direction. What is theta? A straight line, but opposite. Opposite. 180 degree. Very good. Okay. So this is B vector. It means the angle is 180 degree. Therefore, theta is equal to 180 degree. Take down. Theta is equal to 180 degree. So when theta is equal to 180 degree, now it means a 2 pi. You know very well that is a cos 180, how much? Minus 1. Okay. So in that case, you can say that is R is equal to the whole square root of A squared plus B squared plus 2AB of minus 1, because cos 180 is equal to minus 1. So A squared plus b squared minus 2ab, right? So it means that is a minus b the whole square root 2. Therefore, a minus b. So r is equal to a minus b. And that is why the relative velocity will be what? A minus b. Do you understand this? Okay. The resultant will be a minus b. Got this point? Okay, so it means that is when it is a plus b, this is maximum. Okay, so when you are able to get the maximum value, tell me when theta is equal to 0. Okay, take down. So when theta is equal to 0, you got the maximum value. When theta is equal to 180, you got the minimum value. Are you able to follow? And a square root of a square plus b square means in between value. That's all. Okay. Now we can combine, I mean, extend to any number of vectors. For example, now, as I already discussed about the two-dimensional vector, we can talk about the three-dimensional vectors also. How, for example, if it is two-dimension, I can put like this. So this is x-axis, this is y-axis. If it is a third dimension, okay, then it means what we are going in the upward direction. Okay. So in that case, you can involve this is I cap unit vector along x-axis, j cap along y-axis, k cap along z-axis. So in that case, let me try to finish within 5 minutes. Now, that can be, for example, let me consider vector A. It can be considered as a component of vectors, and we can put that is A x, okay, along I, that is x axis. And then you can put a y j cap, and then a z k cap, okay. So can you tell me similarly b, tell me b x I cap plus, tell me b y j cap, b z k cap. And again for c vector, tell me C X I cap. C Y J cap. And then C Z K cap. Okay. Now you are able to get the resultant vector. By combining two vectors, you are able to get R. In this case, combining three vectors, you are able to get the same R with respect to X. So this R vector with respect to X can be written as what? Which is nothing but that is AX plus BX plus CX. Okay, so this can be represented nicely like this. So similarly, RY vector, okay, resultant vector can be what? That is A, tell me, Y plus B, Y plus C, Y. And similarly, R is that vector. How much? A, what is that? A, Z plus B, Z plus C, Z. Okay. I hope now you are able to understand the meaning of this word. So, before concluding this class, I would like to stress one important thing, that is properties of addition of vectors. So that is a very important one. So properties of addition of vectors. Okay. Take down. So first property, there is a commutative law. Okay, take down one. Commutative. Commutative means it can be interchanged and you will get the same answer. It means, for example, when I have the vector A and add to B, then it can be B plus A also, both results the same one. Okay. Then associative law. Associative law means, okay, associative. Associative, let me consider the third vector. For example, this vector A is combined with vector B, and then it is combined with vector C. So this can be, for example, I can combine with A, B plus C vector, and then it can be associated with the A vector like this. Okay, so this is called associative law. And addition properties obeys distributive law. So distributive law means distributive law. It means, so for example, let me have some scalar quantity or magnitude. Okay. So scalar quantity of A plus B means this scalar quantity vector, scalar quantity can be combined with individually also, distributed also, like a lambda A vector plus lambda B vector. Okay. So these are the essential properties. And you have got a fourth property also. So you are able to get the same vector when it is combined with the null vector. So that is equal to A vector only. So all these four are very important. And the next class I'll be discussing with some examples. Then I will proceed with the subsequent vectors. So this vector algebra is a very, very important, and you have to listen it carefully and practice it. Okay.